So yesterday we were talking about the replication controller, right? Okay. So we were talking about the replication controller. We will not use a pod YAML file to deploy an application because a lot of disadvantages are there. As we discussed, if we are using the replication controller, then we can achieve the high availability, right? So let me log into the master machine. Okay, so yesterday we deployed some applications, kubectl. So we just now powered on our machines. So whatever the replication controller we created, we can see that replication controller also with the help of kubectl get rc. So here we can see what name we have given to the replication controller, and this is the values we can see desired current ready. Okay. So again, if we check now, if you see these are in the running state because we powered on the machines. So once the worker nodes are available, then automatically this pods came online. So the major advantage of this replication controller is high availability. So we have only two worker nodes, so that's the reason two pods has been created on one worker node, and the third one is created on another worker node. So now what you can do, you can scale up and scale down also. So how we can do that? So you can execute kubectl scale RC. You can give in a short form RC. The name of that replication controller. So this is the name of the replication controller, nginx and hyphen hyphen replicas equal to, let's say if I give 5. So this is a command we can use, and it's been scaled up. And if you check now, you can see 5 now. Okay. And even if you can see now, total 5 pods has been created. So these are the 2 pods which are created recently. So total it became 5. And if you want to scale down, then you can use the same command. If you want only 2, then you can use 2. Again, it's scale down, and you can check the pods are getting terminated and only 2 will be available. Okay. So when we executed the command called kubectl create -f, the YAML file name. So it's created this replication controller. So this replication controller also you can modify. See, on fly I have given the command to scale up and scale down. Another way is to do is modify this replication controller. So to modify this replication controller, kubectl edit rc nginx. Okay, so it will open in a YAML file format. Okay, so now this is the configuration, and here if you see replicas equal to 2. So that replication controller has been modified with the command which I executed, the scale down which I have done. So here also you can come down and you can give, let's say 4. Now it is showing as a 4. So changes has been applied. So what are the changes we have done to that configuration? So it has been updated, and we can see the pods also, 4 pods will be created. So this is a purpose of replication controller. Okay, and how come replication controller knows that it should increase these pods or decrease whatever we are doing the changes? Replication controller, how it is getting identified that it need to be increased or decreased specific pods. See, replication control is separate. It got created. This is a replication controller. So pods are separate. How come this replication controller knows it should increase only these pods and decrease these pods? With the help of labels. We call it as in selectors. So if you observe, I'll open
Praveen, can you please tell the command again for creating this thing replication controller?
creating
Yeah.
any object. If you are creating, the same command we will use: create kubectl create -f and the YAML file name. What are the YAML file we are using? So for this, I was using, or see, this is the YAML file I was using. So inside that, whatever the specifications you give, what objects you define to create, those things will be created. So this file contains, I will open this file in the Kubernetes page. Okay, replication controller Kubernetes. Okay, if you see the same file, so whatever I copied it from here, and I, guys, can you please go on mute? Okay, so the same file it is. If you see this RC, this is the same file. I copied it from here. You guys also can copy it from here. So you just search replication controller Kubernetes, then you will get the main page. So there you can able to get this file. Okay. So if you see here in the spec field, you can see selector app. Okay. And template, this name is also showing the same name. So with the help of these labels, replication controller, you are telling replication controller that, okay, so these are the applications are getting deployed. This is the app name. This is the label name. So with the help of this selector, replication controller knows that, okay, these are the pods. It needs to be increased or decreased, whatever the activity we are doing. Okay. So if you don't mention this selector, then replication controller will not able to scale up or scale down. Okay, because it don't know which application it need to be scaled up and scaled down. So that's why for replication controller, we can see this as selector and app equal to nginx, and here the same, again you are giving the name nginx and labels equal to app for the container. So that's why it can able to recognize. Okay, replication controller knows that these are the applications with the label names. So why we use labels? So here, whenever we are creating any deployments, we'll give labels. Why? Because to identify easily. Hundreds of pods will be there. Now, if I type kubectl get pods, it will show hundreds of pods. From that, you want to see the information about only some application pods. For example, one application is having 8 pods. You want to display only those 8 pods. You want to see the information. Then for all those 8 applications, we can give label of that application name, so that we can see kubectl get pods -l label equal to whatever the label name was assigned to that one. Then we can able to see only those pods. So that's the reason we give labels. And selector means what? This label is using by some other entity to select. Okay, you are giving a matching that this label name, like how we are giving here in the replication controller, identifying specific applications with this label name, so that we are selecting. So that is called as a selector here. Okay. But this replication controller, if you observe, API version is showing V1. V1 means, as I said yesterday, those are old objects, means very initial stage they might be created. But now the alternate has been introduced by the Kubernetes for this replication controller. That is called as an replica set. Okay. So what is this replica set? On almost same, but only thing is the difference between replica set and replication controller is majorly into this selector field. Okay, this is about replication controller. This is old deployment type. Now replica set. So how replica set works? Replica set is defined with fields including a selector that specifies how to identify pods it can acquire, a number of replicas indicating how many pods it should be maintaining, and a pod template specifying the date of new pods. So here major is selector. So the remaining everything is same. Okay, but only thing is the difference between the replication controller and replica set is this selectors. So it will be like so here quality based selectors and replica set are set based selectors. So this is the difference between these two. Okay. So what is this quality based selectors? Quality based selectors like equal to, double equal to, and uh, not equal to, means this will give uh, in the selectors tabs. Okay. And set based selectors are mm, in, not in, and exists. Okay. So here how we are going to define this, the major disadvantage here is we use selectors to match labels, right? So here only we can give one key one, only one value. Let's say um, for example environment equal to, let's say we can give production or maybe development, and this way what it will do, in the key value pair it will just only filter the labels equal to environment equal to production, only one value you can give. And let's say tire, if you give this one front end, means this is not equal to, means whatever the tire you have, front end, back end, or apart from any other tires, among all them you don't want to display only front end. Okay, so not equal to means what, if you are giving front end means apart from front end tire, all the remaining labels whatever is there in the tire field, it should be displayed. Maybe back end is there, some other applications are there in the tire field, so all will be displayed. If you give equal to means what, if you don't give this one, it's equal to means it will display only front end parts. Okay, you labeled it as a front end, and that front end parts only will be displayed. But if you give not equal to means it is not going to display front end parts, and it is going to display all the remaining parts. So only this way you can give. But whereas in a replica set, so what it is going to do, so here you can give in environment in, and here you can give multiple values also. So it will display production and it will display QA, and if you give another dev also, it is going to give. Okay, and not in, tire not in means you don't want to display. Then front end, back end, like this you can give multiple values. So if you want more about this, you can search with quality based selectors.
If you can please zoom in a bit.
So is it not visible? Still you want to make it more zoom?
When you use a notepad file, then.
Okay. Okay, so you can get more information about this quality based selectors and set based selectors when you are using replication controller. Okay. So, but still we don't use replica set or replication controller to deploy our applications in the real-time environment, whether it's maybe production or non-production environments. We don't use replica sets. Okay. So which one we'll use, I'll discuss later. Before that, I would like to discuss about the another type of deployment called a stateful set. Okay. So we have discussed replication control and replica set. Now we'll discuss about stateful set. So what is the stateful set? Some kind of applications will expect stateful set. Okay. So what those kind of applications we'll see. Stateful set. So here, so these are all the deployment types, how we are deploying the applications on the Kubernetes cluster. These are different ways. So this is one of the way to deploy. Stateful set is a workload API object used to manage stateful applications. So manages the deployment and scaling of the set of pods and provides guarantees about the ordering and uniqueness of this pod. So like a deployment, stateful set manages pods that are based on identical container spec. Unlike a deployment, stateful maintains sticky identity for each of their pods. So these pods are created from the same spec, not interchangeable. Each has a persistent identifier that it maintains across any rescheduling. So here, when we use this stateful set, because first of all, the Docker or this Kubernetes we are using, mostly these are for the stateless applications. Okay. So what is stateless and stateful? Can anyone tell me what is the difference between stateful and stateless?
Volumes are saved, volumes are not saved.
So stateless means the application is not going to store any data. Okay, even if the container or even if the pod dies, we are not bothered about the data. Okay, it means we don't want the data. Those are called as the stateless applications. If you are bothered about the data, you want to store the data, then those are called as stateful applications. Means we are expecting the data. Because again, if a new pod is getting created, it should use the old data which was created by the old pod. So means there should be a volume concept should be there. So volume contains the data. The new pod gets created and that new pod should use that volume so that it can access the data. So these are called as the stateful applications, which is going to store the data. The applications which doesn't require data, those are like a stateless. So basically, maximum applications will use the um, stateless applications only. But sometimes, like for example, database you are deploying, okay, and for example, for log aggregation, we are installing Elasticsearch, Kibana, okay. So it collects all the log information data, right? So we need the data. If the pods gets deleted, then the logs data will also get deleted. So if I want to search last 1 week logs, then it will be not available. So it need to store the data. So then it should maintain a volume. So some applications are required to store the data. For those applications, we allocate a volume. Okay. So those are called as the stateful applications. And here when we use this stateful set, so another difference between this replication controller or replica set and this stateful set. So when I mention 3 replicas, stateful set will not go and deploy parallelly at a time. Okay. So first it will create one pod, and once it is up and running, then only it will go and create second pod. And once second pod is ready, then only it will go and create the third pod. Okay. So that way it is going to create. And while deleting also, what it will do, it will delete the third pod first, and once it is deleted, then only it will delete the second pod, and then it will delete the first pod. Why when this concept is useful? Because see, whenever, let's say, we are going to maintain for example in the database, if you take mm, for sometimes you want the pods like a active passive kind of scenario. Okay, so you want to run an active passive. I hope you guys are aware about active passive. Active passive means active will receive the traffic, passive will not receive the traffic. When active goes down, passive will become as an active. Again, when active recovers, then again passive, whichever the passive was become active, that will become as a passive. This was using in the traditional data centers like for clusters or any virtual machines application high availability. Okay, so that concept you want to achieve here. When you are creating 3 pods in 3 replicas, okay, as a replication controller or replica set, the traffic will come to all the 3 at a time. There is no passive active, it will receive traffic. But here only one will be active and another will be passive. Okay, so in this scenario, when you are creating, when the deployment has been done with this replica set, then parallelly it will create. At a time both will get created and both one will become active. So you want to write a mechanism which that it will do kind of election, or like it will tell that okay, this will become master and this one will become slave, or this one will become active and this will become passive. To achieve this, it should create one by one, not parallel at a time. Okay, so then in that scenario, if any applications are expecting uh, to maintain this, then those kind of applications are going to be used stateful set as a deployment type, so that one will become master or active, and second one will become either slave or maybe passive. Okay, the example is RabbitMQ, and RabbitMQ is a messaging queue. RabbitMQ, and another example is Elasticsearch. So these two deployments types we use stateful sets. Okay, RabbitMQ, the templates. You see here stateful set. This is a YAML file. Actually, this is in the Helm chart, so that's why it is taking from the values.yaml file. When we talk about the Helm chart, at the time I'll explain you. Okay, only you can see the kind is stateful set here. So here RabbitMQ, when we deploy, so it is going to deploy the applications in an active passive, like master slave concept will be there. 3 pods will get created, and one will be active and remaining will be standby concepts will be there. So RabbitMQ messaging queue will be there. So based on that, it will work. And Elasticsearch. So we have a concept called Elasticsearch. Okay, log aggregation. At that time, I will show you by showing this example using the stateful set deployment file. So we can able to deploy the log aggregation. Okay, means so here what happens, it will create Elasticsearch pods. 3 pods gets created, but one will become master and remaining 2 will become as a slave. So this will connect to the another pod will be there, Kibana. Kibana is a dashboard front end to access the logs. So Kibana will always contact this machine, means whoever is the master. So in between, it will elect this as one machine as a master, and Kibana dashboard will connect to that, and it will collect all the data from the database, and it will view. We can view in the visualization. Okay, GUI. If anything happens to this pod, then among these two, it will elect another as a master, and Kibana will able to connect to this one. And the same thing, it contains all the data over here also. Okay, so this way we can able to access the dashboard. Okay, so in this scenario also, Elasticsearch uses stateful set. Okay, so why? Because it's going to elect. So immediately all the pods will not create parallelly. One by one it will create, then only the mechanism what it is configured for election purpose to select one is the master or one is the active, then only it will be helpful. If you use replica set or another type called deployment, this one or this one, it is not going to work, only this one. So only for few kind of applications we use stateful set, not for all the applications. Maximum all the applications we will go with the parallel should be created. All the pods will be, as I said, these examples only we use stateful set. Okay, I will show you this example practically when we talk about EFK, Elasticsearch, Fluent, and Kibana topic log aggregation. At the time we use the stateful set, then I'll show you practically about that. Coming to the daemon set. Daemon set also we don't use frequently. So why we use daemon set? In one scenario I will explain. Majorly this is also for logs only. Okay, like EFK, Prometheus. Okay, these two, this is for actually log aggregation. Most of the people will think that both are for same purpose. No, this is for log aggregation and this is for metrics like CPU, file system, network utilization, disk utilization. All this information will show. This is logs, error logs. Your application is corrupted or shut down, stopped, your server is down, your OS is not working, the logs to monitor, to troubleshoot. This is the log aggregation. Prometheus is for metrics monitoring. So we have an cluster and assume this is a cluster, and now as I said, we need to deploy EFK. EFK here is Elasticsearch, Fluentd, and Kibana. This is the three different tools we are going to install to achieve this log aggregation. Okay, so what happens? Elasticsearch. mm, this one. Okay, if you see here, this is one worker node, and this is one worker node, and this Elasticsearch and Kibana is also deployed on one worker node. Okay, so this Kibana pod is also running on one worker node. Elasticsearch is also working on one worker node. So here Elasticsearch is to store the data, but from the worker node, how the data has been transferred to the Elasticsearch with the help of Fluentd. Okay, so EFK means this is Elasticsearch, Fluentd, and Kibana. So Elasticsearch will store the data, and that data is going to be visualized. We can view with the Kibana dashboard. But how Elasticsearch is getting data? With the help of Fluentd. So Fluentd is sending the data to the Elasticsearch. So how Fluentd is sending? It is in this worker node, whatever the pods got created, it will collect all the logs, Kubernetes logs, and if you configure application logs, all those logs will send it to the Elasticsearch. And this Fluentd is responsible is to send all these logs from this to here, Elasticsearch. Okay, and it will store the data, and this Kibana will connect to the Elasticsearch, and it will send. Okay, and we can able to view the data from the Kibana dashboard. So now, if this Fluentd, so when I deploy this EFK deployment, okay, so this EFK deployment should be deployed with the daemon set deployment type. Why? Because the specialty of the daemon set is when I deploy this, and only this Fluentd I'm going to deploy with the daemon set. Elasticsearch already we discussed. It is going to be deployed with the stateful set. So let's say we have elasticsearch.yaml file. Inside that kind is stateful set, and Fluentd kind is daemon set. Okay, so this Fluentd, when I deploy this tool, this application, the kind will be daemon set. Why we use daemon set? Because when I use this, if I have three worker nodes, so three worker nodes, what it will do? Three pods will go and get created inside three worker nodes. In the daemon set deployment file, I'm not going to specify the replicas here, but still it will go and create three pods. How? Because of this daemon set. How many worker nodes you have, on those many worker nodes, one pod go and create. Let's say in future, due to heavy load, one more worker node has been created. Without any manual intervention, this Fluentd daemon set will go and deploy another fluentd pod inside this one. This feature is not work with stateful set or replication controller or a replica set or maybe this deployment. This is not possible because in this you are mentioning replicas, how much you want, 2, 3, only those many will be created. And in this replica set or replication controller or deployment, if you mention 3, it doesn't mean that compulsory those 3 will go and create in these 3 worker nodes. Sometimes 2 might be created in one machine and 1 might be created in another machine. If the, for example, resources are not available in this machine, maybe 2 might be created here, 1 might be created here. End of the day, it needs 3. But here, every worker node, from every worker node, we want logs should be transferred to the Elasticsearch. Then in every worker node, compulsory one fluentd pod should be created and it should collect all the information and then it should send it to the Elasticsearch. So Elasticsearch also might be somewhere here or here, the pod. So it should send. But we are talking about the fluentd pod, which is getting created. So if you are creating daemon set deployment, then compulsory here we don't define any replicas. When you deploy, master knows that how many worker nodes we have. So it will go and deploy those many pods inside those worker nodes. And if new worker node gets created and inside this worker node also pod gets created automatically. And what are the, this is fluentd pod. So whatever the application pods are deployed, apart from fluentd, there will be a lot of other pods will also get created like application pods. So all the pods logs information and the cluster logs information collects by this fluentd and it will send it to the Elasticsearch. Elasticsearch might be somewhere in this one or this one. Then it will send that information to the Elasticsearch. Okay. So in this specific scenario, fluentd will be deployed with the daemon set. The same way in Prometheus also we have a concept called node controller. Then Prometheus also will collect all the information from this worker nodes and it will send to the Prometheus server. From there, same like Kibana, we have Grafana dashboard. So Grafana will connect to the Prometheus server and it will get the information. We'll have a separate session for these two, EFK and Prometheus. So there we'll discuss detailedly. But the good example for stateful set is Elasticsearch and good example for daemon set is for fluentd. Okay. So apart from this, apart from fluentd, I never seen any real-time usage for applications to be deployed for fluentd. In case any such application should be deployed in each and every worker node, then we may use fluentd. But majorly we use daemon set for fluentd only, and daemon set we use it for Prometheus to deploy. Okay, so that is another deployment type. So we don't use it regularly, only for this fluentd or Prometheus we use daemon set. So we have discussed all this. So this is a major important one. 80 to 90% we use deployment to deploy the applications. Okay, because this is the latest one introduced by the Kubernetes with lot of features. So how you deploy, how many features you have. So in deployment, you have different types of deployments again. So which is recreate, rolling update, blue green, canary. So these many deployment types are available inside this deployment. Okay. So now we'll discuss. So always remember in your real time, you need to use this type. Okay. So kind deployment you should use. So again, while using deployment, if your product owner or maybe your application owner will ask you while you are deploying, how you are going to achieve high availability, how you are going to achieve whenever you upgrade the applications. Your major reason is when you are upgrading the application without downtime, how we are going to upgrade the applications in the Kubernetes cluster. That is important. So for that, which option you are going to use? Recreate, rolling update, blue, green. So we have separate topics for this one. Okay, I'm taking separate session for rolling update, blue, green, and canary. Just as of now, I'll just give a brief idea about it. Okay, because we'll have a practical session for these three. We cannot achieve this in practical, but these three we can have a practical session. Okay, so now I'll go to the so this is a API version is apps v1 because this is the latest one. So so if you see here, roll back to an earlier deployment version. If the current state of the deployment is not stable, each rollback updates the revision of the deployment. Scale up the deployment to facilitate more load. Pause the deployment to apply multiple fixes to its spots template and then resume it to start a new rollout. You can pause the deployment also and check up older replica sets. So here when you do deployment, along with this deployment, replica set will also get created because in the deployment.yaml file, you will define this is a kind deployment and this is the API version. And here you see replicas equal to 3. So because of this, backend automatically replication controller also will get created. Okay. So here, so we can use, I'll just give a brief introduction to this. What is recreate? Recreate in the sense when your application is getting deployed. So those applications, let's say if it is using Nginx image 1.14.2 here. Okay, we are just taking an example. In application for your microservice might be having some version. Okay, so if you upgraded a new thing, new developers has been upgraded few things and version has been changed, then that version you want to deploy, then here you can create, you can use recreate option. Okay, so in this specs field we will get a option called strategy and there we'll use a recreate. And if you deploy the applications with recreate option, then what will happen? So the applications will be deleted the old pods and it will create a new pods. Means completely it will be deleted old one and it will create a new one. That is a recreate. Rolling update is so mostly we'll prefer rolling update. So let's say your application is having some version, assume 1.1 version. Okay, and the same you have three replicas. You mentioned three replicas, and now when you mention in your deployment.yaml file here inside the here we'll get option called strategy and there we'll give rolling update. We'll see if it is available here. No, that example YAML file is not available here. Maybe it will be available inside the rolling updates. So inside the YAML file, we'll give when we deploying the applications itself at that time, we'll define whether we want recreate or rolling update. Mostly we don't use recreate, we'll use rolling update. So at that time, what it will do, let's say by default already three pods are there. And again, what we need to do, we need to go and change the version of the application, okay, inside the YAML file. assume in this scenario image is 1.14.2. Let's say I went and changed the image version 1. Some 16.2 or 15.2, something like that. When I change and again when I redeploy this application, means when again I am going to execute kubectl create-f and this deployment file with the latest image version. This image contains latest version. So what it will do, first it will create one pod, okay, and then what it will do, it will delete the old version of one pod, and then it will create another pod. After that it will do delete this one, and then it will create third one. After that it will delete this pod, and now these are running with the latest version. Okay, let's say this is 1.2. So the traffic will be available here. Okay, now afterwards you realized this is not a stable version. Okay, the stable version is not working. Then you can roll back to this previous version. That is possible. And here not only this version, let's say 1.2 is there, 1.3 is there, 1.4 is there, like that multiple versions. These are things we can configure, like how much of history we should maintain, revision history. Based on that we can roll back to our previous version here, so that again these pods will be online with this version, and this will be terminated. So that is an advantage in the rolling update. And coming to the blue green is one type of another type of a deployment. This is also majorly we use it for when we do application upgrades. So how to reduce the downtime, that is the major important reason we are using blue green or rolling update or canary deployment. So blue green deployment will be like, so already one environment will be there. Let's say this is an environment, and this is a, so total this will be running with the old version, and this will also will be running the newer version. Means I am going to create another deployment with the latest version, but real-time traffic is coming to only to these servers. So what I'm going to do, I'm just change the labels to the load balancer, so that traffic is going to be routed here. Okay, so parallelly both will be running, but when I route the traffic will be routing here and to the latest version. Once it is stable, we can delete this, or else if something happens, if it is not stable, then again we can route the traffic to the old pods. Okay, this is called blue, this is called green. So this is called the blue green. We'll see practically how we can achieve that. So in the meantime, now just I'll deploy this deployment type. Okay, and before that I'll delete this kubectl get pods. So when I was talking about a replica set, so replica set responsibility is to maintain the high availability, whatever the numbers we have defined. So if you delete a single pod, always remember, don't delete the pods if you are deploying the application with deployment or replica set or stateful set, because again it will recreate. You need to completely delete the deployment. Means here kubectl get rc, you need to delete this one to delete all the applications. Okay, you should not delete the individual pod. If you delete, again it will get recreated. So if you see kubectl delete pod, because replica set or replication controller responsibility is to maintain the value what we have defined. So it will recreate once again what are the pod, because value is not matching. We mentioned 4 and it is only 3. So immediately it started creating this one. But if you delete this kubectl get rc and kubectl delete RC Nginx. RC means replication controller. kubectl get RS is replica set. Okay, so already I'm using this replica set for one of my like dynamic NFS provisioner. Okay, so this is a one replica set is available. So if you want to deploy an application with replica set, we can deploy it. So now I'll deploy this deployment type in this one. Now vi, you can give any name, deployment.yaml. So this is an Nginx image, it is going to be deployed. And if you see the remaining, all these things are same. If you see in the replication controller also, replicas, selectors, these all are same. Okay, but only the kind deployment will get more features. Means inside this more options you can add. Those options you cannot add to the remaining kind, like stateful set or daemon set. So for deployment, you can create a strategy here and you can add rolling update or recreate options. Okay, now kubectl create -f. Now kubectl get, first of all you need to check deployment. Okay, so this is the one which is getting created 37 seconds ago. So this is a deployment name because it is defined inside this name is nginx deployment. That's why it is showing. Now if you can go and see the pods, these are the 3 pods got deployed. 3 has been mentioned, and you can see kubectl get deployments to see the deployment, and you can see kubectl rollout status. We'll discuss more about this rollout command. Okay. Sorry, rollout status, deployment. Okay, so deployment engine is successfully rolled out. It is showing. So we need to give the deployment type and the deployment name. So it is showing the rollout status. Okay, so and now if I show you RS, when I was checking with the RS, see here, it was showing only NFS client, right? Now I did not create a replica set, but automatically replica set will be get created. If you see Nginx deployment replica set. Why? Because this deployment is using replicas equal to 3. So that's why backend it's created replica set also. Okay. So when I talk about rolling update and blue green, I will show you why this replica sets gets created. Why? Because I'm saying here in the previous example, I told you rolling update. Okay. So if I want to roll back, we should have this set of pods. Okay, it will be not available, but that replica set will be created, that will be available. Okay, so I will show you clearly in the practical of when we are doing rolling update. At that time we can see two replica sets, one with this version and one with this version. So when I'm doing rolling back, this replica set get enabled and those pods will come online. Okay, so when this one again, these two replica sets will be available in the backend. Okay, deployment will be one, but two replica sets will be created with old image with the latest image. So when you want rollback, that's how it will get it from the information here. That we'll see in the practical when we talk about rolling update and blue-green deployments. Okay, so updating a deployment, we can update it. So with this command, if you see, means any image latest version, if you want to update it, let's say I'll execute this command, or this command also you can use. kubectl set image means what we are doing inside this YAML file, cat. um, this is the version. Okay, so now here in this command it is using this version. So it will update this image in the configuration. So I open another tab. I'm using watch command, kubectl get all. Okay, so here if you see, this is for NFS client replication controller, and this is for Nginx. Okay. Hmm. Hmm. Okay, this way I can get the image version also here. Okay, now I'll go back here and I'll execute this command. Now if you see here, Nginx image, and here if you see pods got creating here 3 seconds, 5 seconds, 11 seconds, container creating. So it's creating with new image, terminating and creating new image. So now all these three are running with the new image. If you want to check kubectl get pods. So these are the new containers has been created. And if you want to confirm, you just browse with an IP curl HTTP and take any of the pod IP address. There is a version here.